Okay, so we're going to review some of the practice problems for Unit 4, Lesson 9. Number 1, cell phone plan A costs $70 per month and comes with a free $500 phone. Cell phone plan B costs $50 per month but does not come with a phone. If you buy the phone and choose plan B, how many months is it until your cost is the same as plan A? So if we look at our two plans, plan A, we don't pay for the phone, but we pay $70 per month. For plan B, we don't get the phone, and so we pay $50 per month. Plus, we have to pay $500 for the phone, right? So for plan A, we don't pay for the phone, but we have to pay more every month. Plan B, we buy the phone for $500 and then we pay less every month. So we've got to decide how many months until our cost is the same. So you've got to come up with a plan to decide how many months into the cell phone bill will, like, let's say that you sign up for plan A and I sign up for plan B. How many months into our paying, our bill every month, how many months until we've both spent the same amount of money? Now, what's interesting about this could actually be something that you would want to determine if you were buying a cell phone and a plan is, if it's only 3 months, maybe that makes one plan better than the other. If it's 3 years to pay back this free phone, that might be not a good idea for you or your family. So this is actually something that people really think through and really do to decide, is this $500 free phone they're giving me really worth it? Or is it better to just get the phone? So you have different options. You can try to set up an equation. You can lay out how much per month and you can compare and you can add up, as you go. Just remember that the $500 on plan B is only one time, right? It's like a one-time charge. So you set this up how you would like, and the final answer is 25 months. And now that I'm telling you the answer, you have to show the work. So you have to show a way to show how you could get 25 months as your answer. Now that's your job. Number 2, Priya and Han are biking in the same direction on the same path. Han is riding at a constant speed of 16 miles per hour. Write an expression that shows how many miles Han has gone after T hours. So it's 16 miles per hour that he's riding. So 16 miles in 1 hour, 32 miles in 2 hours, right? So 1 hour would be 16 miles, right? 2 hours would be 32 miles. 3 hours would be 48 miles. And if we look at the pattern that's happening, if we take 16 and multiply it by the number of hours, we actually get, let me do that the other way. If I do 2 times 16, I get 32 miles. 3 times 16 is 48 miles. So if I take the hours and I multiply by 16, I get an expression. So our answer for A would be 16T. If T stands for hours, It's 16 times the hours. So for B, Priya started riding a half hour before Han. If Han has been riding for T hours, how long has Priya been riding? So Priya started riding a half hour before Han. So if I take Han's time, I'm going to add half of an hour, right? So I'll take Han's time and then I add half an hour to it. So it says Priya started riding a half hour before Han. So if Han rode for 5 hours, Priya was riding for five and a half. If Han rode for 10 hours, Priya was riding for 10 and a half because she's a half hour ahead. Now make sure that you write your T in a way that you can tell the difference between the T and the plus. C. Priya is riding at a constant speed of 12 miles per hour. Okay, so Priya's speed is 12 miles per hour. Write an expression that shows how many miles Priya has gone after Han has been riding for T hours. So if we look at A, the expression in A was for Han's speed at T hours, and we got 16T. Now in C, Priya is 12 miles per hour, so you would think it needs to be 12T. However, not quite. Let me do it like this. Not quite, because we're writing this in relation to Han's speed at T hours. And if you remember in part B, we take Han plus a half hour for Priya. So instead of 12T, we're actually going to say T plus 0.5 because we're relating it to Han's time. So Priya rides 12 miles per Han's time plus 0.5. And now D is where you're going to do some work. Use your expressions to find when Han and Priya meet. So they're going to meet when their distance is equal. Okay, so they're going to meet when their distance is equal. So it's kind of like Han is riding over here on this bicycle. Pretend that's a bicycle. And Priya is riding over here on this bicycle. When are they going to meet? Okay, so in order to figure out when they're going to meet, we're going to make their expressions equal to each other. So now it's your turn to solve this equation. You can keep the 0.5 as a decimal, or you can change it to 1/2. Whatever feels easier to you for solving. And I will tell you the answer, I'm not going to write it down, but the answer is Han rides for 1.5 hours, Priya rides for 2 hours. Now, even though I'm telling you the answer, I expect to see your work on that paper to get your points. Number 3, which story matches the equation -6 plus 3x equals 2 plus 4x? So you're going to have to look at the information in both of these problems and decide which one seems to match up with these equations. Now, a couple things to remember, because I'm not going to give you the answer on this one. A couple things to remember is look at the variable and what the variable represents. So in A, a temperature change at the same constant rate, x degrees per hour throughout the night at both locations. The temperature at the first station 3 hours after this recording is the same as the temperature at the second station 4 hours after the recording. So them being the same and being equal is good. X degrees per hour, 3 hours. Maybe the 3x matches with that. 4 hours. Okay. At the beginning of the question, it says the temperatures recorded at 2 weather stations in Antarctica are -6 degrees and 2 degrees. That looks good. But double check for against B. Elena and Kieran play a card game. Every time they collect a pair of matching cards, they earn X points. So the X represents the points. So if we look at the equation, we have 3x and 4x. So if we look for the 3 and the 4, we can kind of decide if things match up. It says after Elena collects 3 pairs and Kieran collects 4 pairs. So if x is points, does the equation match up if we have Elena collecting 3 pairs? Would that be a 3x? Okay, so those are the kind of things that you want to look at to help you determine the answer to 3. Number 9. For what value of x do the expressions 2/3 x plus 2 and 4/3 x minus 6 have the same value? That means when are they equal? So you have to figure out what the x value is in this equation. I'm going to get you started. So I have some fractions here I don't want. My denominator is a 3, so I'm going to do what's called clearing the fraction. I'm going to multiply both sides by 3, specifically 3 over 1. Okay. As long as I do the same thing to both sides, I'm not doing anything wrong. And what's going to happen is the 3 is going to distribute inside. 3 times 2/3. Now you don't need to write it this way, but I'm going to just, in case you need to see it, becomes 6 over 3 x plus 6. Distribute the 3 on the right-hand side, becomes 12 over 3x minus 18. And what we're going to get is 6 over 3 actually simplifies to 2. 12 over 3 simplifies to 4. And what you'll actually notice is if I would have cross-canceled, my 3's actually canceled and I was left with a 2. The only thing, and be very careful if you're cross-canceling like this, because I don't want you to forget that you still have to distribute the 3 over to the 2. So be careful with the notation there. So from here, it's your job to solve this out, and you'll get a solution for x.